Hey, kia ora, Nisambul Vinaka, and hello. My name is Dr. Neil Pandey. I'm the Academic Director, Research and Operations here at NZSE. I'll be hosting you today, joined by leaders in education and industry to celebrate the launch of our NZSE's engineering program. Very exciting, with New Zealand Diploma in Engineering Electronics Level 6.
Kia ora, everybody.
Thank you, Louis. So we are now going to hear from our first speaker. We are very fortunate to have Louis Harvinger. He's the General Manager, Health Technology Management, Procurement, Supply Chain, and Health Technology Management with Tīwhātua Ora. Louis, thank you for joining us today. Louis is an experienced senior leader in health technology management with diverse background, spanning over 30 years and across international public health organizations. He is very passionate about collaboration. Louis currently holds a pivotal role in orchestrating to deliver the safer, more efficient healthcare initiative for Tīwhātua Ora Health New Zealand. With expertise in clinical engineering, asset management, procurement, project leadership, Louis spearheads transformative initiative, including establishment of the National Health Technology Management Function. And may I add, Louis has been very pivotal in developing the clinical engineering, which is part of the electronic specialization of NZDE. So thank you, Louis, and welcome.
Thank you, Neil, and thank you for the opportunity to be part of this launch. Very humbled to be here. Like you said, very passionate about the qualification and very keen to help. So I've been asked just to talk through a few questions. So the first question was, could you please put electronics engineering into context of everyday life, illustrating the huge impact it has on people's life? So I'll start off to say electronics is part of our lives these days. It's all around us. And we've seen through the innovations and the stream of digitalization of mechanical devices and the Internet of Things that we are just seeing more and more equipment and electronics around us and the connectivity with us. And this is very specific to medical devices as well. So in the medical device field, we've seen a major transformation since the 1980s that led to the increase in people's life expectancy and a significant improvement of health outcomes. And those are due to medical devices. The technology advancements in medical field are due to the invention of the that led to the integrated circuits, that led to miniaturization of components and the programming of machine. And today we're seeing also the impacts of artificial intelligence and machine learning, and especially that is being sought and seen in the medical field. The medical field has advanced, like I said, over the last 40 to 50 years. And we, as Tīwhātua Ora, have noticed that we've got over 1,000 different types of medical devices in one of our academic hospitals. And those are different machines that we use for the prevention, diagnosis, monitoring, alleviating, and treating and curing of diseases, ailments, and defects and injuries. So you may relate to some of the medical devices, thinking of a basic tympanic thermometer. If you go to your doctor, he takes your core temperature by using a handheld thermometer that uses infrared to measure the temperature inside of your ear. And we also see on the other side of the continuum, very complex machines called linear accelerators, called LINACs. And these devices are used for treatment of cancers. They are most commonly used external beam radiation treatment. And what the LINAC does, it speeds up electrons to deliver therapeutic X-rays or electrons to a patient tumor. So very complicated and very sophisticated machines. So what we also say is medical equipment plays a significant role in our well-being. And this was quite evident if we think back to our COVID-19 over the last few years that we've seen, and the pivotal role ventilators and high-flow oxygen delivery units played to keep people alive. And as we saw on the news, there was a major shortage of those devices in certain countries. So again, you can see electronics is all around us, but especially in the medical field, has got a significant role to play for medical devices. So my next question that I was asked is, how is working in electronics engineering exciting? Does it challenge you to innovate and adapt to technology changes? So I thought about this question a wee bit, and I thought I'll talk you through some of my lived experience. So I started my career many, many moons ago as electronics technician after completing a similar qualification in a different country. I started off working in the building management sector, installing and maintaining building controls and automation systems, which were very fascinating and exciting. But one day I was working in a hospital and I was installing cables and sensors, and I stumbled into the clinical engineering department, and I was fascinated by these machines that it was flashing and beeping and making noises. And through my curiosity, I started chatting to one of the clinical engineering technicians, and this led me to apply for a role with them. My electronics knowledge and skills were transferable, so I could use what I've gained in a different industry and apply it to clinical engineering. And in the personal career in clinical engineering, I've moved into, of course, other aspects like asset management, health technology management, procurement, and others to support clinical equipment. But I think the important bit here is my curiosity and love for medical equipment and clinical engineering has driven me to keep abreast with innovation in technologies. And I've seen over my career a significant proliferation of digital medical equipment and the evolution of information and communication technology landscape that introduced electronic patient records, because there's a big uptake in electronic records, which stores data and images and results that is acquired from medical devices directly into patient records. So we're becoming more paperless in our hospitals. So the New Zealand Diploma in Electronics, especially with the specialization in clinical engineering, will open several career opportunities in several electronic fields, and even specialization within clinical engineering. So coming back to the Linux, working on very complicated and complex machines, and that will be facilitated through having that baseline qualification. But I would also add, with the Dublin Accord, this qualification is also recognized internationally. And this, and like myself, opened doors for students and candidates to travel overseas and to use that skills in other countries. So the third question I was asked was, what does the engineering sector look like currently? Equity in clinical engineering. And so for me, I've reflected on this, and on reflection, found that we've been very fortunate in the clinical engineering sector that we've got a multicultural and quite a diverse workforce. In Te Whatu Ora clinical engineering team, we're over 230 employees. And historically, this was a very male-dominated profession. But in the last 8 years, we've seen a significant shift to attract female members to our team. And they've been very a good asset for us, and they've accelerated in their careers. And we've also seen them taking on more and more leadership role, which is excellent for our profession. We've been working very hard with educational sector, like Neil and company, to establish the NZDE program for clinical engineering and specialization. In this program allowed us over the last few years to develop local talent, and that is job ready. And I believe that all that graduated from the previous course have moved into successful roles across the country. So as you can appreciate, working in health and with the population growth that we are seeing an increase in demand in the healthcare sector that's driven through this growth, but we also see a significant increase in medical device uptake and need for more medical devices, which mean somebody needs to maintain these. So therefore, we do need more engineers and local talent to be developed. So I'm very excited with this course, Neil. I'm very keen to support this going forward, especially around the clinical specialization, clinical engineering specialization. Yeah, and I wish you and NZSEC all the best to deliver this going forward. So over to you, Neil.
Thank you, Louis. Thank you very much. Yes, it's very exciting, and you are absolutely right. The population's growing, more people means bigger hospitals, more equipment, and more people are needed to service these equipments. I've just got one more question I'll ask you, Louis. What does the engineering sector look like currently in terms of job opportunities, especially in Te Whatu Ora or in clinical health or health sector? What's your thoughts around that?
Oh, no, there's a great career opportunity to enter, and job opportunities are available. Like I said, we're 230 odd staff currently in Te Whatu Ora. We've got an aging workforce, so we will need to start thinking of new talent and new skills coming into our workforce. But we're also evolving, and like I said, we are taking on more and more equipment, more and more responsibilities. So therefore, we will need more and more engineers to support that. Now, currently, we're sitting around 24 vacancies across the nation, so there is definitely jobs. Okay. Like I said, we're multicultural. Historically, we relied quite heavily on bringing people from overseas, attracting overseas candidates. And that's why I'm so excited with this course, to see how can we grow our own talent and develop our own local talent pool.
Sure, and that's 24 job opportunities only with Te Whatu Ora. Wider health engineering sector, there'll probably be more job opportunities out there.
There will definitely be more in the private sector as well.
Well, it's very exciting, and we are very excited to go on to this journey alongside with you, Louis. Look, thank you very much, Louis. You have, as I said before, you have been very instrumental in developing the qualification. And I must say, for the audience, Louis has been kind enough to donate a lot of actual medical equipment that have been used in the hospital, functioning medical equipment that we now have got them in our NZC electronic lab. So we are very proud of that. So really appreciate your support, Louis, in ensuring that the students that we will be teaching those courses are actually using the devices that are actually being used in the hospitals, and so that when they do go into the workplace, they are seeing equipment that they have actually played around with in our labs. And so there's nothing new that they are seeing. They are already hopefully working job ready when they come to you and applying for a job. So look, thank you very much, Louis. I'll get you back once the question time comes up, but I really appreciate your time. And once again, thanks for your support.
You're welcome.
Thank you, Louis. I would like now to have the second speaker. We've got Alan Lyons. If I can get you to turn your camera on, Alan.
Kia ora, Neil. Kia ora, everyone.
Kia ora, Alan. Thank you very much. And just a bit about Alan. Alan, thank you very much for joining us today. A bit of a biography of Alan. Alan is a very experienced chartered engineer with background in nuclear and high hazard facility operations and control. Alan is passionate advocate for inclusion and diversity in STEM, working across secondary and tertiary education sectors in New Zealand, underpinned by a 20-year career in Royal Navy's surface ship and submarines, marine and nuclear engineering. Alan's expertise lie in driving best-in-class engineering governance and assurance, technical risk management, product safety outcomes. Alan also serves as a member of both NZSE Group and Auckland University Industry Advisory Group. Alan, thank you for your support on our NZD. And must I say, Alan is also a keen beekeeper and a radio amateur. He also likes to be out on the water fishing, rod in hand whenever possible. So welcome, Alan. Welcome to our launch of NZD, and thank you for your time today. Let me just quickly remind presenters, please keep putting your questions in the chat. If you have got questions, we will come and address your chat once we have done all the formalities, and we will be giving you information pack when needed. So let's get started, Alan. I'll go through the questions with you to just make it more interactive. What is contributing to the increase of demand for electronic engineering skills? Is the industry experience in terms of skill gaps? What are your thoughts around that?
Yeah, thanks, Neil. So So I reflect on that biography, and I think what it says is if you're around long enough, you'll have done some stuff. But what I'd like those of you on the call and on this launch today to think about is that the reason I've managed to achieve all those things is because there's been people around me who have supported me on that journey, and it's the main reason I'm here today. It's not good enough for industry to be good at finding good people. We know that we're good at finding good people, but what we need to do is stop the pipeline losing so many good people before we get the opportunity to see them. So us working in the tertiary sector, Neil, and in secondary is really, really important for us as an industry, but for our role in New Zealand. So electronics. And again, for those of you on the call who are looking at what should you do, this is really a picture I'm painting around why you should choose electronics. I think that what we've seen is electronics has suffered from a few things. There are a whole bunch of shortages out there in the engineering space. However, some of them are being more successfully filled than others, and the one I think that's really suffering is electronics. If I stand in, when I'm at AUT, I stand in first year's mechanical engineering. It's a room full of hundreds of students. Yes. For them, I say, how are you going to stand out? When you look around that room, when I see the amount of computer science and the growth in that space, it's really great to see, but I wonder whether those people that are applying for those courses realize the competition that is building up for them in that space. Electronics, I believe, has suffered from the success of mechatronics. So what we're really seeing in industry is some really capable cross-discipline engineers, but we need deep specialization in the electronic space. And of course, what the statistics also say is it's not all about degree qualified engineers. We need those engineering technicians. I think the statistics say we need 4 to 5 technicians for every graduate. And the stats that I saw, we were achieving half. So this is a real need for the country. It's a real need for industry. It's a real opportunity for somebody who's choosing their subject. And having spent half of my degree doing electrical and electronics and really enjoying aspects of the electronics, I think that if you're brave enough to take the step, then electronics will see you having a fantastic career in the future.
So I guess that leads to the next question, the problem that Diploma can solve for industry, as you mentioned, 4 to 5 technician per engineer.
It's actually a great stepping stone in both directions, isn't it? It builds up, a real competence that, as Louis said, makes you industry ready to go into that, that technician pathway, which is massively short and is real, realization of engineering, or to take that next step and complete a degree in that sort of space. So it's a really awesome pathway to start on, definitely.
Great. And you also mentioned you do need engineers, but there's also space for technicians, specialist technicians like electronic technicians, because as Louis mentioned earlier in his talk, wherever you see there's electronics all around you, and that's probably where the future of the job is. What's your opinion on that?
So I suppose there's a few aspects. One aspect is the challenge industry has with electronics is the cycle time, and that's the opportunity for the engineer, right? So it's so technology is changing rapidly, and to maintain a capability, we need to keep developing that technology. You need to develop. It's easy to think, and I think this is a trap that students can fall into, that that your concentration is on the design aspect of the technology. The reality is we have to. There is R&D, there is design, but we then have to sustain this for 20 years when it has a cycle time of 5. So there's a huge amount of work to be done in the support and sustainment space. And what we see is it's a real struggle to find competent people in this electronic space. Yeah, definitely.
And engineering in itself is quite exciting. Why would you think a career in engineering be satisfying day to day life?
So so it's about problem solving, right? I was really in Louis' speech, I heard a bit of a why, so for that greater good, why do you, and in a way, in a sense, I think that might turn out to be the stream of industry that you end up in, because in engineering, you're going to be solving problems. I talk about problem solving in 3 different ways. You might be a person who needs to, to have your room on fire before you can get excited enough to solve the problem. Short-term, highly important problems that need solving in real quick time. That's a type of engineer that we need. Then we have on the other end of that, more in the design space, the ability to stay focused on something that will be needed, but people don't realize is needed yet for a number of years, and working across a bunch of supporting functions and disciplines that don't know they need to help you today. So in that design space, you're a type of person who likes to solve problems over a year to 2 years, and you're working a lot in that grey. And then in the middle, it's very seldom that when you solve a problem, there's one solution, right? Problems are complex, and options to solve problems are many. So in the complex, this might take you anything from a week to 6 months to solve. There's a whole load in there. So for me, it's what type of problems do you want to solve? Because in engineering, you'll be able to solve any one of those 3 different types of problems, depending on what gets you out of bed in the morning.
Thank you very much for sharing your thoughts today with us, Alan. That was really interesting, especially the comment you made, and I guess that Louis made the same comment, is about growing our own pipeline of people, with the qualifications such as our engineering program. So once again,
I think that's what we're here. I think that's what we're here for, Neil, right? But the people on the call, what they need to hear is it's their opportunity, right? Where there's a shortage, it's an opportunity. Where you think it might be something that people don't necessarily want to do, it's your advantage. I love nuclear safety. I love regulation, governance, and assurance. Not a lot of people like that sort of stuff, which makes my career, a really great opportunity for me. So again, electronics, there aren't thousands of them out there. Not everyone loves it. Not everyone's up for the challenge, which is an opportunity for everyone who wants to apply.
Thank you, Alan. Thank you very much. And as question comes up, I'll bring you up again for the question time.
Yeah, no,
thank you
pleasure.
For your time.
Thanks. Yeah.
Thank you. Okay, our next talker. Thank you very much, Dr. Jack Lee. Dr. Jack Lee, just a bit of a quick bio around Dr. Jack. Dr. Jack is a program director for Bachelor of Engineering Honours and program at AUT, and he's a professor in School of Engineering, Computer and Mathematical Science, Faculty of Design and Creative Technology with AUT University. Welcome. Thank you for your precious time that you've given us today for our launch of our diploma program.
Thank you, Neil.
Okay, Jack, I'll just quickly go through some of the questions we've got here and like to hear your opinion on those questions. How can a dynamic relationship between companies and education providers a better outcome for our learners, especially for our young learners who are looking at, bridging that theoretical and theoretical knowledge with practical knowledge? What are your thoughts on that?
I think, first of all, a good relationship between the industrial partners and the education provider can help the students to find a good intensive environment. For example, at AUT, for Bachelor of Engineering Honours, the students are required to complete 800 hours of internship before they can get the graduation certificate. So through this one, the students will notice the difference between the theoretical knowledge and those knowledge used in the industrial environment. Secondly, with the industrial partners, they can advise us, for example, on the currency about the curriculum, which means we usually have an industry advisory panel to help us to revise the curriculum for a periodic pattern. For example, every 3 years we have a we have a yearly meeting. Every 3 years we have a like a review of the current curriculum. Then besides that one, we also occasionally invite industrial partners to come to for a guest lecture, so they can share with us the recent development in the industrial environment. They can also inform us about the current challenge they are facing in the company. So I think a good relationship between industrial partners and us is very important for the success of the students' learning. Thank you.
Yeah, exactly. Thank you, Jack. That's absolutely correct. You know, if we are teaching in isolation without industry partners, we'll be obsolete in no time. So that's a very, very good point. What do you think when hiring, do employers look for practical experience in candidates? Like if we got students, like you mentioned, 800 hours, does that help students secure a job?
Yes, exactly. Most of our students, they found the first job through the internship project. Because of the 800 hours, they stay with the employer. Then the employer may notice, okay, this student's very good in terms of technical skills, in terms of interpersonal communication skills. So this one will help them to secure their first job. I think when I came to New Zealand in 2013, I also noticed that because at that time my wife was looking for a job. She employer, they always ask for, and do you have any experience working in New Zealand before? But at that time it's quite difficult, especially for the first job. So that's why if you have some working experience during our study, then this one will help you to find a job.
Yeah, absolutely.
That's a very important factor for job hunting. Thank you.
Thank you. Thank you for the check. And what skills do you think makes a good fit for an electronics engineer position? You know, what do you think makes a good fit?
I think in terms of the technical skills, they should be familiar with the fundamentals. They learn all the theoretical skills. They learn the technical skills to operate the instruments. For example, how to use the software, how to use the different equipment during the lab sessions. Besides that one, another one is the lifelong learning, which means they should keep a learning attitude. Even they graduate, they obtain the degree already. When they are working in a company, they still should be, willing to learn new knowledge. Then in terms of the soft skills, I think the communication skills in terms of the interpersonal communication skills, for example, how to give a presentation in front of a group of people, how to write a piece of technical report, then how to write, the email, because nowadays working in a company, they usually write a lot of emails. How to write a precise email is very important. Beside that one, the time management, for example, how to meet the stringent deadline in working in an industrial environment is also important. I think the last one is the financial management skills. For example, most of industrial projects, they have a very tight budget. So how to realize the solution for a certain problem, you need to follow the financial management. So that's why financial management skills is also very important. Thank you.
Thank you. Thanks, Jack. And if you can sort of peek into the future, ways the engineering's advance our lives, you know, what would that be? What's the future of, especially in electronics industry, you know?
Yes, just like the first speaker, Luis, and the second speaker, Alan mentioned, first of all, our society is aging, which means the number of elderly people is going to increase significantly. So we probably need to live with robots in the future. So another one is the rising of the artificial intelligence. A lot of systems will be, controlled by AI. Or another like a computer. So how do you differentiate a human from a robot? In the future will be very difficult. So which means the boundary between human and machines will be become blur. So in addition to that, we also need to think about the renewable energy. For example, with the increasing usage application of AI, we need a lot of electricity. We need a lot of embedded systems. So that's why electrical and electronic engineering will be very important for our future. Besides that, we also will see the increasing importance of computer security. So that's why we will see a lot of devices around us. How to ensure the secure communication among the devices will also important. So that's why I can see a bright future for electronics and electrical engineering in the future. Not because of I graduate from electrical and electronic engineering. It's because our future is going in that way. For example, the vehicles, I think in the future will be autonomous electrical vehicles. So we need the electricity, we need the control algorithm, we need AI, we need the robots. So we need electronics for this one. Thank you.
Thank you, Jack. I think very interesting. Yeah, electronics is an area which is growing up. So it's really, really important that, we do have a good pipeline of our own homegrown engineers for future. I'd like to thank you, Jack, for sharing your thoughts around engineering, especially in the electronics engineering. As mentioned previously, if we have got any questions at the end, we will come back and get you on to answer a few questions on the chat. So thank you once again.
Yeah, thank you.
Jack. Thank you. Yeah. Okay, well then, team, engineering actually is very interesting, very exciting space. Where we have got problem solving. Not only it's you've heard not only technical knowledge, but also soft skills is quite important. So you need to be a good listener, you could be a good communicator, you could be a good presenter. At engineering, here at engineering, being an exciting space, we are quite excited about offering our program, and hopefully we create our engineers for future who can solve problems. And that's why we are so excited about launching our new engineering program. I'm going to do a presentation, but just before that, just give you a reminder. Now, normally it takes around about, our program starts on 15th of July, and it takes currently around 60 days to get a visa. So please, as a reminder, if you want to be on this journey of our new inaugural delivery of NZD program, your visa application should be in place, and to secure your spot, just a slight reminder, I'll actually go off to my presentation now and give you a bit more around the details of the program, what the program looks like. I won't go into too much of detail because at the end of the program, at the end of this program, we will send you an info pack, and hopefully we can answer some of the questions that may be sitting in the chat at the moment. So just bear with me and I'll start my presentation. I'll just give you a quick run through our New Zealand Diploma in Engineering, Electronics Engineering Strand Level 6 program here at NZSE. Thank you to our speakers of today. We had Louis Havinga. You've heard about his thoughts around clinical engineering. You've seen Alan talk about the importance of growing our own pipeline, and then Dr. Jack talked about, what skills you need, not only the theoretical needs, but also the practical knowledge and the soft skills that you need to be a successful engineer. So thank you today for the speakers. And later on, we'll have a chat Q&A time, the questions that may be in the chat. Okay, if I move on to the... Okay, so how important is this diploma to New Zealand? It's actually on the green list with Immigration New Zealand. In 2022, we had about 6,880 new jobs that were created in NZ Tech sector, growth which is year on year. It's not going to slow down. And as you've heard from our speakers, the population is growing. The demand for technology is increasing as we keep talking about it. This qualification, you heard Louis mention, it's under Dublin Accord. Now, Dublin Accord is an international benchmark for engineering technician qualification. So, when you've completed this qualification under Dublin Accord, that's going to spark some success internationally and bridging, students to industry worldwide. You'd be able to go out and be an electronic technician wherever that international benchmark under Dublin Accord is recognized, and that some countries like UK, US, Australia, and a few others. Just some stats around there. You can see in 2025, we had 149 million new digital technology jobs that were predicted, that are created globally. That's a seriously big number. And we do know population do grow. So that number I'm envisaging is going to keep growing up. And that's why we need more engineers. And that's why this program we are so excited about launching today. You've heard the series of shortages of engineers in New Zealand. And New Zealand in NZSE is the only PTE that is delivering this NZDE electronic specialization. So, that in itself is quite exciting for us, and we are thrilled to have this program. And our intention is to work closely with industries such as Te Whatu Ora to ensure that our students are getting some industry input, whether it be by guest lecturers. And so that's how the program will be designed and be delivered. A little bit more detail on the technical side of the program. New Zealand Diploma in Engineering is a level 6, 240 credit 2-year program. Electronic engineering specialization is the main specialization with a sub-specialization of clinical engineering. And again, it's under Dublin Accord accreditation. Now, the program itself will be delivered here in the city campus on our 238 and 242 Queen Street in Auckland City. It will be an on-campus delivery. It's a face-to-face delivery starting on 15th of July, 2024. We already have our lab, dedicated electronics lab, as you can see, is all set up, ready to go. And as I mentioned earlier on, there are medical equipment that have been donated kindly by Te Whatu Ora, and thanks to Louis for that in supporting us. That will be pulled out from time to time when we offer clinical engineering courses. In terms of meeting the entry requirement, you need for NCEA level 2 and above. For NCEA level 2, we'll be looking at 48 credits at level 2 in 4 subjects, including 12 credits in maths. Engineering is all about problem solving, so maths is quite critical. You need to have achievements in algebra, calculus, trigonometry, preferable. Our language requirement for international students, we have to have an IELTS language requirement of IELTS of 6 with no individual score less than 5.5 or a 5th level. If you don't have if you don't have NCEA, don't worry. We cater for all. If you're a domestic student and you don't meet the NCEA requirement, we have a level 3 engineering foundation program that even goes for international students if they don't meet the entry requirement. Or if you have got an equivalent qualification of NCEA level 2 as long as you've got a pass mark of more than 50% or more in all the courses, and including maths, you'd be, we'll be looking at providing an alternative entry pathway. Or if you've got if you happen to be a tradesperson who is working here and looking at upskilling yourself, even an electrician, or have worked in the industry and you think that you'd want to have a formal qualification, then please definitely get in touch with us. Some more detail will be sent in the info pack. Just a quick overview of the courses. I don't expect you to remember or read all of it. Just it's 4 semesters, 2 years. Each semester, a student does typically 4 courses. Just to highlight the 4 courses here in the second year is where you can do clinical engineering courses together. And you can then at that point in time choose whether you want to do clinical engineering or you want to do electronics engineering. The first year program will be common, and then from second year you can decide whether you want to do electronics specialization, coming out doing all the electronic courses, or you want to do the clinical engineering. The 4 courses in electronics are there, electronics and microcontrollers, and whereas the clinical engineering, you're talking about anatomy and physiology, medical equipment 1 and 2, and fault finding. So what are the benefits benefits to the students for doing this? You'll come up qualified to work as an engineering technician. It's a critical area of economy in New Zealand and overseas, especially New Zealand is on the green list. You'll be learning broad skills in electronics engineering, and you can develop specialist knowledge in electronics industry, as well as in, if you want to do clinical engineering, there's a specialist knowledge. 4th semester, we have a capstone project. We aim to work with the industries to solve real-world problems, so that will be an opportunity for you to do some capstone project work there. Graduates who can work as a technician level is outlined in the Dublin Accord, and Dublin Accord is under the International Engineering Alliances, and that's what gives you the portability of working overseas, those who recognize. Engineering New Zealand, who is a standard setting body in New Zealand, do have a chartered member category under engineering technician for Dublin Accord graduates, which is the diploma program we are talking about. So in years to come, once you have got experience, you can become a chartered member as an engineering technician with Engineering New Zealand. And you can also serve as a pathway into undergraduate engineering qualification. That's we've talked with Dr. Jack Lee here. For example, you can finishing our engineering diploma program, transforming into the BE program or the Bachelor of Engineering Technology program. Just a picture of a technical, a technician's day in life, and what all the equipments are, medical equipment and electronic equipment. These are tools that are being used for our graduates who work as a technician. Industries that are in demand for NZD graduates, we've talked about aerospace, we look at automotive, defense, electronics, hospitals, medical devices, the list goes on and on and on. So, there's a huge need for electronic technicians in the industry. Background pictures of some more electronics, robotics, security, space, endless opportunities for technicians. Just a quick, I don't envisage you to read all of it, but a typical graduate these days of a 2-year diploma in New Zealand earns around about $65,000 of salary. Now, this is not my figures. This is actually figures provided by the remuneration survey from Engineering New Zealand in 2022. So it's actually a decent salary that the technicians earn these days, as once they come up with a 2-year diploma qualification. I'm actually also quite thrilled and excited to announce some scholarships. At NZSE, we got 2 Rama scholarship program, and we are excited to announce the scholarship program in engineering. So there will be 2 scholarships for our Maori learners in engineering, and then 2 scholarships for our Pacifica in engineering. Details can be found on our webpage. And again, more information will be in the information pack. Question times. Now, I do understand, it has been so exciting, and launching our NZDE. We have got, phenomenal speakers who gave their insight of what's happening in the industry. And I think we have just run overtime, and, we've got allocated an hour to do all our mahi today into that hour. My sincere apologies. We do want to stick with the hour that we have been allocated, which means we have eaten into our question time. I'm really sorry about that, but it's actually been exciting hearing the industry partners. But please don't worry. We will receive we have received your questions in our chat. We don't have any time for questions. However, we will respond to your questions, and also our information pack will have those as well. But at the same time, I'd like to once again thank our speakers. Louis, thank you very much for your time, and Alan and Dr. Jack, once again, thank you very much for your continued support. We really appreciate your time today, and I am really, I really apologize that we don't have time for questions, but be assured we will come back to you with the responses if you've got questions in the chat line. And yes, NZSE will help students on their journey. We are excited to hear from you. As I mentioned, please put in your application. We really look forward to having you on our new journey of engineering program here with NZSE. As you have seen in the photos, the labs are ready. We are ready. We want you to come and open the doors for your success to become an electronics engineer with our program. Thank you very much, team. And once again, to the listeners, thank you for your time. Thank you for joining us today and be part of our launch of NZDE program. We really appreciate your time, and you'll hear from us soon. Thank you.